Hello children, welcome back to the digital class. I hope you are all doing well and you might all be excited to learn some new and interesting concepts in today's mathematics session. So, let us begin our session. Before that, let us quickly recap what you have learned in our previous session. Can you identify the image shown on your screen, children? You are right, it is a geometry box. Now, what are the instruments that you have seen in this geometry box, children? The one which you notice on your screen? Yes, it is a ruler or a scale, and the image shown on your screen is a right, it is a protractor. Then what about this image, children? You are right once again, it is a compass. Then the image shown on your screen, this instrument is a divider. Now, finally, take a look at these instruments shown on your screen. These are the set squares. But do you know, children, what is their use? You are right once again, we use these instruments to construct some geometrical figures such as line segment, angle, triangle, circle, etc. Children, do you know what a triangle is? Right. A simple closed figure formed by three line segments is called a triangle. And children, do you know the different types of triangles? You are right once again. Now, these triangles can be classified based on their sides and angles. Now, based on their sides, we have scalene triangle. In this type of triangle, all the three sides will be different, whereas in the second one, that is isosceles triangle, any two of its sides are equal. Finally, we have equilateral triangle. Now, in this all the three sides are equal. Now, let us move on to the types of triangles based on their angles. The first one is acute angled triangle. Now, in this all the angles are acute, that means they are each angle is more than 0 and less than 90 degrees. Whereas, the second one obtuse angle triangle, in this one of the angle is more than 90 degrees, that is obtuse angle, and less than 180 degrees. And finally, we have right angled triangle. Now, in this triangle, one of the angle is a right angle, that means one of the angle is equal to 90 degrees. Now, do you know what is meant by a geometrical construction? Yes. A geometrical construction is the process of drawing a geometrical figure using only two instruments, that is an ungraduated ruler and a compass. Now, in today's session, that is geometrical constructions part 1, we are going to construct different types of say angles and also triangles. So, by the end of this session, you will learn construction of perpendicular bisector of a given line segment, construction of bisector of a given angle, construction of an angle of 60 degrees, and finally, we will construct types of triangles. So, first we will learn what actually a perpendicular bisector is. A line which divides a line segment into two equal parts at an angle of 90 degrees is called a perpendicular bisector. Let us understand this, children. Now, consider a line segment AB. So, it has some fixed length. Now, I will draw a line L, now which is intersecting AB at say some point O. Now, this line L divides AB into two equal parts, that is OA and OB both are equal. Not only that, it makes an angle of 90 degrees with AB. Hence, we say L is a perpendicular bisector of AB, because it is dividing AB into two equal parts and also making an angle of 90 degrees with AB. So, children, now let us learn about construction of perpendicular bisector of a given line segment. Let us take an example. Draw the perpendicular bisector of a given line segment AB and write its justification. Let us start the construction. First, we have to draw a line segment and mark the endpoints of the line segment as AB as shown. Now, take the compass and place the pointed end of the compass at one of its end point. So, we have placed it at A, and now adjust the other end, that is the pencil side. It should be more than half of AB, children. Now, fix that as radius and draw an arc above the line segment AB as shown on your screen. Again, with the same center A, draw another arc on the other side of the line segment AB. Now, place the compass at point B, that is the pointed end, and without disturbing the compass, that is same radius, we are going to draw two more arcs. Now, I will draw one arc here, it is intersecting the previous arc, and draw one more arc such that it will intersect the other arc also. Now, we got the point of intersection of two arcs. Now, mark them as P and Q. Now, let us join the point of intersection of these two, that is PQ, using a ruler or a scale. Now, we have joined this. Now, this PQ, whichever is formed, is intersecting at point O, that is O is point of intersection of line PQ and line segment AB. And also it is, if you measure, you will notice that OA and OB are equal. Not only that, this line PQ makes an angle of 90 degrees with AB. Hence, I can say that PQ is a perpendicular bisector of AB. So, children, we have seen how to construct a perpendicular bisector of a given line segment. Now, let us see its justification, children. Let us join the points A and P and also A and Q. Not only that, we will join points B comma P and B Q also. Now, consider triangles PAQ and PBQ. Now, in these two triangles, I can write PA is equal to PB. But why PA and PB both are equal, children, here? Yes, they are equal radii. So, we have drawn arcs of equal radius, right. So, that is why both PA and PB are equal. Apart from that, I can write QA and QB are also equal. The reason is same thing, that is equal radii. Now, if you notice, PQ is the common side for both the triangles, that is PAQ and PBQ. So, I can write the reason as common side. If you notice these two triangles, that is PAQ and PBQ, three sides of one triangle are respectively equal to three sides of another triangle. What can we say, children? Yes, triangle PAQ is congruent to triangle PBQ by SSS congruency rule. So, by CPCT, that is corresponding parts of congruent triangles, I can write angle APO and angle BPO, both are equal. Okay, children. Now, let us consider the triangles APO and BPO. Now, in these two triangles, I can write AP and BP, both are equal. Second, what is the reason, children? Yes, equal radii. Then we have angle APO equal to BPO. Just now we have proved it, right, by CPCT. So, these two angles are equal. And if you notice, OP is the common side. So, that means in these two triangles, so that is triangle APO and BPO, two sides and included angle of APO and two sides and included angle of BPO are equal. Now, what can you say about these two triangles, children? Yes, triangle APO is congruent to triangle BPO. So, this I can write it by SAS congruency rule. Again, by CPCT, I can write OA equal to OB. Apart from that, I can write angle AOP is equal to BOP, that is angle AOP, this angle BOP, these two angles are also equal. Now, if you consider these two angles, that is angle AOP and angle BOP, sum of these two is 180 degrees. But why, children? Yes, because they form linear pair. That is the reason sum of these two angles is 180 degrees. But children, we have seen that angle AOP and BOP both are equal here, right. Now, in place of this BOP, I will substitute AOP. Now, on substituting it, what do you get, children? Yes, angle AOP plus angle AOP is 180 degrees. So, we get 2 times of angle AOP is 180. Now, what is angle AOP, children, now? Yes, 180 degrees by 2, which is 90 degrees. Now, since AOP is 90 and we have already proved that AOP and BOP both are equal. Now, what about the measure of this angle BOP? You are right. So, BOP is also 90 degrees. So, from these two, that is OA equal to OB and angle AOP and BOP both equal to 90 degrees, I can say PQ is perpendicular bisector of AB, because this PQ is dividing AB into two equal parts and making an angle of 90 degrees. I hope you understood the justification also, children. So, children, we have seen the construction of a perpendicular bisector and also its justification. Now, let us move on to our next construction, that is construction of an angle bisector. An angle bisector of an angle is a line or a line segment that divides the angle into two equal parts. Let us consider angle AOP. Now, I will draw a ray OC such that angle BOC and angle AOC both are equal. Then I can say that ray OC is bisector of angle AOB. So, let us start the construction of this, children. Let us take an example. Construct the bisector of a given angle AOB. Let us start the construction. So, consider the angle AOB on your screen. We have to bisect this angle, that means we need to divide it into two equal parts. So, for that we are going to take a compass, place the pointer of the compass at point O and adjust the radius and draw an arc as shown on your screen. So, this arc should intersect ray OA as well as ray OB, and mark the point of intersections of these arc OA and OB as C and D. So, C and D. Okay. Now, place the pointed end of the compass at point C and measure CD. You should take more than half of CD and draw an arc in the interior of angle AOB. You can see we have drawn it in the interior of angle AOB. Again, without disturbing the compass, that is same radius, draw another arc with D as center, so that both the arcs intersect each other. Mark the point of intersection as E and join OE using a ruler. So, let us join, children, OE. Now, this ray OE which is drawn is nothing but the angle bisector of the angle AOB, because if you measure the angle, you will see that angle AOE and angle BOE both are equal. Now, children, let us justify this bisector of given angle AOB. So, for this again we need to join points DE and CE as shown on your screen. Now, let us consider triangles ODE and OCE. Now, in these two triangles ODE and OCE, I can write OD and OC both are equal. But why, children? Because they are equal radii, right? Then DE and CE are also equal. Why DE and CE are equal? Arcs of equal radius. Then OE is the common side to both the triangles. So, OE equal to OE. Now, I can write these two triangles, that is ODE and OCE are congruent to each other. Why? Because three sides of one triangle are respectively equal to three sides of another triangle. So, therefore, by SSS congruency rule, I can say both the triangles are congruent. So, by CPCT, I can have angle DOE and angle COE both are equal. That means, OE becomes now bisector of angle AOB, because this OE is dividing angle AOB into two equal parts. I hope you understood the justification also, children. Let us move on to our next construction, that is construction of an angle of 60 degrees at the initial point of a given ray. Let us take an example. Draw a ray OP and construct a ray OQ such that angle POQ is 60 degrees. Let us start the construction, children. Take a scale, place it horizontally and draw a ray. So, mark the end point, that is O, and another point we are marking it as P. So, here OP is the ray, and take a compass and place the pointed end at O, and with a convenient radius draw an arc as shown. So, we have done this previously also, we are drawing an arc. Now, we are going to mark the intersection point, the ray OP and the arc as A. Now, place the pointed end of the compass at point A without disturbing, that is same radius. We are going to draw another arc on the previous arc. Mark this point as B and join OB using a ruler. So, let us join this, children, and extend it. So, mark this ray as say OQ. Now, here POQ is the required angle, that is 60 degrees. So, let us see the justification, children. So, this is what we have done in the construction. So, let us prove this. I will join AB. Now, if you notice in triangle AOB, can I write OA equal to OB? Why, children? Because radii of same arc. Similarly, I can write OA and AB are also equal, because we have drawn the other arc also from A having same radius. So, arcs of equal radius. Now, from these two, that is OA equal to OB and OA equal to AB, I can write OA, OB and AB, all these three are equal. That means, in triangle AOB, all the three sides are equal. Hence, we call this triangle as an equilateral triangle. Each angle in an equilateral triangle is 60 degrees. That means, angle POQ is equal to angle AOB, that is equal to 60 degrees. Till now, we have seen some basic constructions such as perpendicular bisector, angle bisector, and also we have seen constructing an angle of 60 degrees. Now, next we will move on to the construction of triangles. Let us construct an equilateral triangle. So, children, we have already seen an equilateral triangle is nothing but all the sides are equal in it. So, let us take the example. Construct an equilateral triangle given its side of length 4.5 centimeter, and also we have to justify the construction. So, let us start with the construction, children. In the first step, we are going to place a scale horizontally and draw a line segment of length 4.5 centimeters, because it is given that the side of an equilateral triangle is 4.5 centimeters. So, here I am marking the base AB whose length is 4.5 centimeters. Now, place the pointed end of the compass at 0 on the scale and adjust the length to 4.5. You can see, children, we have adjusted the length as 4.5 and place the pointed end of the compass at point A and draw an arc above AB as shown on your screen. Now, place the pointed end at point B, that is with the same radius. We are going to draw another arc such that it should intersect the previous arc and mark the point of intersection as point C and join BC using a ruler and also join AC. So, the triangle which is obtained here, that is ABC, is an equilateral triangle as all the three sides are equal. So, let us see the justification, children. So, your triangle ABC is given to us in this, all its sides, that is AB, BC and AC are equal, because that is radius of equal arcs. Now, since all sides are equal, we call it as an equilateral triangle. So, this is the justification for this construction. So, let us move on to our next construction, children, that is construction of an isosceles triangle. So, let us take an example. So, construct an isosceles triangle given its base and base angle and justify the construction. We are going to take a ruler, place it horizontally and we are going to draw a line segment AB of any given length. Okay. So, I am taking it as 6 centimeters here and mark the ends of the line segment as AB. Now, take a compass, place at point A, and with A as center we are going to construct a 90 degrees angle. So, children, we have already seen how to construct a 90 degrees angle, but why are we constructing here 90 degrees angle? So, let us understand first this one. So, here we are going to construct a 45 degrees angle here and here also 45 degrees. So, we are going to draw two rays with 45 degrees. So, when two angles are equal, the sides opposite to them are also equal, then we get an isosceles triangle. So, we have to actually construct a 45 degrees angle. So, for that we are constructing a 90 degrees angle at point A. So, draw an arc to intersect the previous arc as shown on your screen, and from that point of intersection draw one more arc, that is 120 degrees, you might have seen already, right. Now, we are going to bisect this angle, that is 60 and 120. In between that we are going to draw a bisector, so that we get 90 degrees. So, we are going to draw two more arcs from the point of intersection, that is 60 degrees and 120 degrees, such that both the arcs intersect at a point. Now, join point A with the point of intersection of both the arcs as shown. So, get a ray. Now, this ray makes an angle of 90 degrees with AB. Now, we are going to draw the bisector of this 90 degrees angle. So, for that we will take more than half of this length as shown and draw an arc in the interior of this angle, that is 90 degrees as shown. From there again we are going to place this compass over here and draw one more arc here to intersect the previous arc. Now, both the arcs are intersecting, you can see. Now, join A with the point of intersection of these two arcs using a ruler. Now, this ray which is obtained makes an angle of 45 degrees with AB, that is angle BAP is 45 degrees. Now, let us construct another 45 degrees at B. We are going to repeat the same process, children, what we have done at point A. So, we are going to draw an arc as shown, and without disturbing the compass you are going to draw two more arcs such that it will intersect the previous arc. So, this is the first arc, actually that is 60 degrees. Then again place the compass at that point of intersection, draw one more arc on the same arc, that is the first arc. Okay. Now, we are going to bisect the angle. So, adjust the compass and draw two more arcs such that they intersect. You can see both the arcs are going to intersect at this point. Now, we are going to join this point B and the point of intersection of arcs using a scale or a ruler. So, let us join that. So, now again there is one more 90 degrees angle formed at B. Again we need to bisect this angle B 90 degrees, so that we get another 45 degrees. So, let us bisect it as what we have done in the previous case. So, draw an arc from this point of intersection, and again from this point we are going to draw one more arc to intersect the previous arc. So, you can notice both the arcs are intersecting now. Now, join point B with the point of intersection of arcs using the ruler. So, we are going to draw a ray and extend. Now, mark this ray as some BQ. Okay. Now, this ray BQ and AP both are intersecting at a point. Now, mark this point as C. Now, the triangle ABC which is formed is the required isosceles triangle. So, let us justify this construction, children. Now, in triangle ABC, angle BAC and angle ABC both are equal and equal to 45 degrees each, right. Then I can write BC equal to AC. Why this BC and AC both are equal, children? We have learnt one of the property of a triangle which states that the sides opposite to equal angles are equal. So, whatever the equal angles are there, the sides which are opposite to them, that is this side is opposite to this angle and this side AC is opposite to this angle. So, these two sides also equal. So, since two sides of a triangle are equal, then it is an isosceles triangle. Hence, we have justified our construction also. So, children, we have learnt how to construct a perpendicular bisector, an angle bisector and an angle of 60 degrees. Apart from that, we have learnt to construct equilateral triangle and also isosceles triangle. Now, let us solve few more examples to understand the concept that we have learnt in much better way. Let us start with our first problem. Construct an angle of 105 degrees using ruler and compass and verify by measuring them by a protractor. Let us start with our construction. So, first place the ruler exactly horizontal and draw a ray and mark one of its end point as O, and you can mark the ray as say some OA. Now, place the pointer of the compass at point O and adjust to a convenient radius and draw an arc. So, we have seen we have drawn this kind of arc while constructing 120 degrees, is not it, children? So, in the same way we are going to draw a bigger arc and mark the point of intersection of arc and ray as B. Now, place the compass at point B with the same radius, draw an arc on the previous arc. So, both are going to intersect. Now, mark the point of intersection as P. Now, with P as center and same radius, draw another arc to intersect the first arc. You can see both the arcs are intersecting, mark the point as C. Now, let us join this OC using a ruler. So, we are going to draw a ray now, the end point as O, passing through C and extend it. Now, this angle AOC is actually 120 degrees. Now, we are going to construct 90 degrees angle here. So, we are going to bisect the angle between P and say C, right. So, with P as center and radius equal to less than half of Cp. So, less than this half of Cp, we have drawn an arc. In between these two, we have drawn an arc. Okay, children. Then, with C as center and same radius, we are going to draw another arc such that it will intersect the previous arc. Now, we are going to join the point of intersection of both the arcs and point O using a ruler. Now, this ray which is formed makes an angle of 90 degrees with ray OA. So, now mark the point of intersection of the arcs, that is the ray as OD, okay, and I am marking another point also as X. So, if you notice this angle is 90 degrees, that is angle AOD is 90 degrees. Now, this angle is how much? This total is 120, this is 90. So, this part is 30 degrees. Now, if I bisect this part, I get 15 degrees. So, this 90 plus 15 is 105. Now, we need to draw a bisector for this 30 degrees angle. Now, let us see how to draw the bisector. So, with C as center and radius equal to more than half of Cx, draw an arc as shown. Again, place the pointer at point X and draw another ray such that it should intersect the previous ray. So, now you can notice both the arcs are intersecting at a point. Then mark the point of intersection of arcs as E and join OE and extend. So, this OE is a ray. Now, this ray OE makes an angle of 105 degrees. If you notice, this angle AOE is exactly 105 degrees. So, children, we have learnt how to construct a perpendicular bisector, angle of 60 degrees, and two types of triangle, that is an equilateral triangle and also an isosceles triangle. Apart from that, we have done construction of 105 degrees angle. I hope you understood all the constructions very well. So, before we end our session, let us quickly recap what we have learnt in this session. A geometrical construction is the process of drawing a geometrical figure using only two instruments, that is an ungraduated ruler and a compass. A part of a line is called a line segment. A line which divides a line segment into two equal parts at 90 degrees is called a perpendicular bisector. An angle bisector of an angle is a line or line segment that divides the angle into two equal parts. A triangle is a simple closed figure formed by three line segments. The different types of triangles are scalene triangle, isosceles triangle, equilateral triangle, acute angled triangle, obtuse angled triangle, and right angled triangle. So, children, I would like you to give some assignment to work at your home and submit to your teacher. So, we are going to have some constructions. The first one is construct an angle of 15 degrees and 135 degrees. Construct an equilateral triangle whose length of side is 6.2 centimeters. Finally, construct an isosceles triangle whose base is 5.5 centimeters and one of its base angle is 40 degrees. So, children, with this we have come to the end of our session. I hope you have learnt all the constructions very much clearly. So, with this we will come to the end of our session. We will meet in our next mathematics digital class. Until then, goodbye and take care.